next session, and Mr. Sriram Srinivasan was alumni of our only from Crescent University very few years back. So presently he is in US and pursuing his Ph.D. in the Department of Material Science and Engineering. So he is aspiring researcher with a strong academic foundation in polymer science and materials. As mentioned already, currently pursuing his PhD in the Department of Material Science Engineering at North Carolina State University, USA, where he was awarded a full scholarship. Let me to repeat it. Where he was awarded a full scholarship for his doctoral studies. His academic journey began with us at B.S. Crescent University only, where he completed his undergraduate. During his undergraduate period, he has a lot of interest in understanding the polymer materials, their structures, how they used to behave, the processing methods, and the real world application, because simply studying actually nothing will happen unless otherwise you are not going to check it actually how the in the real world they will work. His academic curiosity gradually evolved into a focused passion for sustainable material solution with a particular emphasis on polymer recycling, recognizing the urgent need of address plastic waste and environmental challenges. He actively participated in various national level technical symposiums, national international level technical symposiums during his undergraduate study, where he won best poster, best paper awards, and that reflects his academic excellence and research potential, as well as the interest with a young age within the age group of 17 to 21 of going for actually that type of interest. He was awarded a full scholarship to pursue it for the total amount as a scholarship to pursue his master's degree at Rochester Institute of Technology, RIT, USA. Building on that foundation, he secured yet another full scholarship for his PhD at NCSU. Currently, he is part of the Narayan Research Group at North Carolina State University, USA, where his research focus is on thin films characterizations. In addition to his academic and research accomplishment, he holds a patent grant and has published papers in several prestigious peer-reviewed journals and has participated in multiple international conferences where he has earned best presentation awards for his work. With a strong combination of academic excellence, research contribution, and global recognition, he continues to advance his expertise in material science with a particular interest on innovation, sustainability, and impactful session. So I welcome Sriram, and Sriram now will take this session. For the last session, this is actually a 6-day FDP program. So participants, I hope actually you have cooperated nicely for last 5.5 days, I can say, because this is the last session. So thank you, you all, as well as actually you have any queries, please ask. Participants, I encourage you actually to ask something so that actually the connectivity will improve. So I welcome Sriram to take the session.
Thank you, Professor Behra. It was a very good introduction, and I'm glad to be a part of this FDP at Crescent. A wonderful evening for those who are in India. I am Sriram Srinivasan. I will be giving a brief overview on the polymer composites characterization of polymer materials, So as mentioned by Professor Bera, I am currently pursuing my Ph.D. in the North Carolina State University Department of Material Science and Engineering. I work for the Narayan Research Group. Um, a brief background about myself. I completed my undergraduate in the Department of Polymer Engineering from 2017 to 2021. During my undergraduate, my research focus was in polymer composites, polymer characterization, and recycling, where I used pyrolysis technique for recycling of plastic and rubber waste. Uh, Professor Samsud Begum was my advisor back in Crescent, and then in my master's, I completed my master's in packaging science at Rochester Institute of Technology, where my research focus was in phase change materials for medical packaging devices, and also sustainable packaging film for various food and produce packaging applications. Uh, my advisor at RIT was Professor Chang Fenga, who has a strong expertise in the field of dynamic packaging. Um, Also, like I was also a student lab manager in the APC Innovation Lab at Rochester Institute of Technology, which actually emphasized the importance of characterization of different materials. So the overview of this presentation will be like I'll be discussing a brief overview on the polymer composites and their application in the aerospace industry, also the importance of characterization, and in detail I'll be talking about the FTAR, DSC, TGA, and the mechanical properties, SEM, etc. So basically, polymer matrix composites, or also known as PMCs, has the polymer matrix and reinforcement. The polymer matrix can be an epoxy resin, phenolic resin, polyimide, cyanate esters, etc. Cyanate esters are especially used for sensing applications. The reinforcement can be fibers, glass, carbon, or particulates such as clay and silica or nanomaterials. Um, what is the importance of polymer composites in aerospace industry? Why are polymers being dominated more than the metals in the current aerospace applications? It is because of their lower density, lightweight, high strength, dimensional stability, moldable properties. For example, like a carbon fiber reinforced composites may offer more strength than a glass fiber reinforced composites. However, the glass fiber reinforced composite has a lower density, so it provides the advantage of a lightweight material. So this is a brief overview of the various polymer matrix composites or polymer based composites used in the aerospace industries, where glass fiber or aramid fiber or carbon fiber has been used as reinforcement depending upon the specific part. Uh, so in aerospace applications, material are exposed to extremely harsh conditions at high altitudes. There are lower temperatures and pressures. The materials also experience rapid temperature changes, strong UV radiation, and constant mechanical stresses. So due to these reasons, the materials which are chosen for the specific application should handle all of these harsh conditions. So the higher thermal stability is a very important aspect, so they do not weaken under extreme temperatures, resistance to environmental degradation, especially from UV rays and moisture, good mechanical strength and durability to withstand stress and vibrations. Also, in order to confirm that the right material is selected for such demanding aerospace application, characterization plays a very significant role. So, what is characterization? Characterization is the process through which we thoroughly understand the material we are working with. In case of polymers, this means looking at several important aspects such as the chemical structure, which helps us determine what type of chemicals we've used. Are we using the right material or not? Also, which in turn plays an important role in determining the thermal stability, the microstructure, the mechanical properties, etc. We use scientific techniques to confirm the material's identity, ensure its property, meet all the necessary requirements, and check any defects or inconsistencies. In short, characterization helps us to predict exactly how a polymer behave under different operating conditions, which is critical for applications like aerospace, where the reliability is definitely non-negligible. So why is characterization important? Characterization is important because it ensures that the right material is selected, as I mentioned before, for the critical applications. Also, it confirms that the quality meets the performance and standards. Also, it helps us to detect any early problems like material damage, contamination, defects from processing. So again, like it is a very important aspect of polymer composites that are being used in such a high demand application like aerospace, etc. So I'll be moving ahead with the different characterizations of polymer matrix composites. So to begin with, I'll be starting with the Fourier transform infrared spectroscopy, which is a chemical analysis. So what is FTIR? An analytical technique that is used to identify the chemical bonds and functional groups in materials. It produces unique infrared spectrum and which is often referred to as molecular fingerprint. This characterization technique is essential uh, for detecting the material composition, degradation, or contamination. Also, it has a major advantage of being non-destructive, rapid, and suitable for solid, liquids, and thin films. Um, in the composite industry, FTAR can be used to understand the specific polymers and additives used in the specific part, detect the defects, and reduce it due to the application of heat, ultraviolet radiation, or exposure. Also, it is widely used for the quality control and failure analysis. Uh, the FTAR works in the principle of Beer-Lambert's law. According to the law, the absorbance of a compound is directly proportional to its concentration. As you can see in the formula, T is equal to I by I naught, where T is the where I is the transmitted intensity and I naught is the incident intensity and T is the transmittance. It can be used for the characterization of colored compounds by recording their absorbance and also used for the determination of unknown concentration of the compounds. Uh, so it so different materials absorb and transmit at different wavelengths in the specific IR field. So the Beer-Lambert's law works perfectly for determining the chemical composition of a specific polymer material. So this is the typical transmittance and an absorbance spectrum of an FTIR spectroscopy. I'll be going in detail with the different plots of the characterization shortly. So this is the instrumentation of FTIR. So I just added a photo from my lab. So it has three main components: the crystal stage, where the flat metal area is the center, and the sample is placed there for the analysis. The pressure arm, um, the pressure arm, which is used to apply the pressure on the sample, ensuring good contact with the crystal so that we get accurate data, and also the instrument body, which houses for the internal optics, infrometer, IR source, and etc. Um, a simple data acquisition for the FTIR spectroscopy is when the specimen is subjected to radiation in the mid IR range from 400 to 4,000 centimeter inverse. So this is a typical IR range which is used to characterize most of the polymeric materials. When the IR radiation is passed through a sample, some radiation is absorbed while the remainder is transmitted, which means that the um, depending on the chemical structure or the different vibrations, which I'll be discussing in a couple of minutes. Each material or the vibration transmits or absorbs at specific wavelengths, which gives a brief idea about what type of functional group it is and how can it contribute towards the final polymer. Also the functional, like the fingerprint region, which is specific for a specific material, can also be analyzed. So these are the basic vibrations, which is the symmetric stretching, asymmetric stretching, wagging, twisting, scissoring, etc., which determines at what wavelength does the absorption or the transmittance peak is observed. So how to interpret the data? So this is a typical FTIR graph, which I mentioned earlier. So it can be divided into two regions. One, the fingerprint regions, and other, the function group regions. So whatever peaks that are observed above 1500 centimeter inverse is the functional group region, and below that is the fingerprint region. So it is key to know that the fingerprint region is specific for a specific material, like the fingerprint of a human being, whereas the functional group can be similar for a wide range of materials. So these are the different functional group peaks which corresponds to a specific functional group that can be observed in that material and is evident by the various stretching as discussed before. So this table shows the typical absorption ranges of functional group in the infrared spectroscopy. These are more predictable regions of the IR spectrum where specific chemical bonds absorb infrared radiations. For example, if you can see here, the CH stretching appears between 2850 and 3300 centimeter inverse, which is common in most of the organic polymers. Um, Also, like the C double bond O, the carbonyl stretch shows between 1680 and 1750 centimeter inverse for identifying materials like polyimides, polyesters, etc., which play an important role in polymer matrix composites used in the aerospace applications. Also, the C single bond O stretches are found between 1000 and 1300 centimeter inverse, which is common in esters and ethers. Also, the OH stretching vibrations of alcohol and acid can be found in the range between 2500 and 3250 centimeter inverse. These functional group regions helps us quickly identify the key features of the composite material. The next important characterization is analyzing the thermal properties of the composite material as they've been used in high temperatures and sudden change in temperature. So differential scanning calorimetry is one of a key technique which helps us to evaluate the thermal transitions and the thermodynamic behavior of the material. So what is DSE basically? This is a key technique for understanding how material behave under heat. It also widely used for analyzing polymers and composites for critical applications in the aerospace. DSC allows us to see how much heat is absorbed or released by material as it's heated or cooled. Uh, Further, this helps us to detect important changes like melting, softening, crystallization, or curing, which are essential information of the material selection and processing at constantly changing temperatures. So why is this characterization very important? This is essential because it gives us important information about how the material behaves when exposed to heat. Firstly, this characterization technique determines the key thermal properties like the glass transition temperature, the melting point, the degree of cure for the thermosetting polymers, which are basically used as the matrix in a PMC. Uh, these values helps in the selection of materials for high performance applications, ensure that the material is very stable under the wide range of operating temperatures. Also, it plays a major role in process development and quality control, helping manufacturers to ensure that materials are properly processed and meet the necessary standards before being used in products like aerospace components. So the basic working principle of DSE is fairly simple. Both the sample and the reference material are heated under the same controlled conditions. The instrument measures the difference in the heat flow between them. If the sample undergoes any physical or chemical change like melting or crystallization, the heat flow will change compared to the reference. These materials are also the changes in the changes are also recorded as the endothermic events where the material absorbs heat, or the exothermic event where the heat is released. This results in heat flow versus temperature curve, which helps us to understand the material behavior with respect to the constant change in heat. So this is a basic DSC instrument. This is a Discovery Series instrument. As you can see here, this is the top view of this specific chamber where the sample is placed. One is used for the reference material, and the other one is used for uh, placing the specific sample of interest. So as you can see here, so the gas purge inlet. So basically DSC characterization runs in a nitrogen atmosphere. The chromal disk is used to place the reference samples and the sample being tested, and the chamber is made up of aluminum so that like it can conduct the amount of heat that is required for the thermal transition in the polymeric materials. The sample preparation, an accurate sample preparation is crucial for DSC analysis. Firstly, we use a very small and uniform sample, usually weighing about 5 to 15 milligrams. This helps us ensure constant heat transfer and reliable results. Uh, the sample is then placed in an aluminum pan or a sealed pan if the material contains volatile components. Uh, they can evaporate during heating. So in order to restrict those evaporations, the material is being sealed under. It is also important that the sample is clean, dry, and weighed accurately. Any contamination or moisture can affect these results. Finally, we use consistent heating rates, typically 10 degrees per minute, and a consistent cooling rate, typically 5 degrees per minute, to ensure that the measurements are reproducible and to obtain comparable data. So it is highly necessary uh, to have meaningful DSC results for the polymer-based materials to be used in various applications. Um, so once the sample preparation is done and loaded, this is how the data is acquired. The heating and the cooling temperatures are determined based on the sample being tested. The rate of heating and cooling is determined, and as mentioned earlier, it is it is helpful, or it is it is a benefit to have a constant heating rate and a cooling rate so that we can reproduce reliable data and more consistent data. Both the reference sample and the sample being tested are heated and cooled, so the number of cycles can vary based on the application. You can go up to 100 or 150 cycles. So once everything is done, you plot the heat flow versus temperature curve. So this particular graph shows the DSC analysis of a crystalline material, where you can see the melting of the material and then the recrystallization of the material. Whereas in case of an amorphous material, there is no recrystallization or remelting happening. There is only one melting, and the material never changes to a solidified form. So, so what are the different peaks or the different curves you get in the DSC analysis? So if you can see here, this is a DSC cycle which has been performed with 2 heating cycles and 1 cooling cycle. Um, so the heating started from minus 25 degrees to 50 degrees, and the sample was cooled back again to minus 50 degrees and heated to the same 50-degree temperature. So this DSC was performed at a heating rate of 10 degrees per degree centigrade per minute, and cooling rate of 5 degrees centigrade per minute. So the various peaks that can be observed here is the TM, which is the point at which the solid form of the material is completely transformed into liquid. The TR, the recrystallization, where the melted material is fully transformed into solid again, and the TG is the gas transition temperature, the point at which an amorphous or a semi-crystalline polymer changes from hard glassy state to a soft rubbery state. Also, like the area under the curve gives us the enthalpy. Uh, Enthalpy is nothing but the amount of heat required for the amount of heat required for melting and recrystallizing the material that is being tested. Uh, However, this characterization has a few limitations. It only provides the bulk thermal properties, does not give any specific information about the microstructural aspects of the specimen. It cannot identify the exact chemical structures or compositions. Complex material may show overlapping peaks, making interpretation pretty difficult. Also, it requires a very sensitive sample preparation. If you prepare inaccurate preparation, may lead to uh, uh, false results. Also, there is a limited availability to analyze highly volatile material without the seal pans, as mentioned earlier. So the next important type of characterization is the thermogravimetry analysis. So it is a thermal analysis technique where we measure how much mass of the material loses as it is heated over time. Also, it helps us detect when the material decomposes, oxidizes, or breaks down, making it very useful for studying polymers, composites, and many other materials. So why is this characterization really important? TGA is important because it tells us how stable a material is when it is exposed to heat. Also, it shows us what temperature the material starts breaking down or decompose. Especially in composites, TGA helps us to estimate how much filler or reinforcement is present. Um, by giving us a estimate of the residue. These informations are pretty critical for selecting material that needs to perform reliably under heat in various applications. So this is a basic instrumentation of the TGA, where the sample is placed in a weighing balance and the sample temperature is recorded below it. The gas inlet is present on the top where the weight balance is present. The heater is present on the sides of the sample holder, and the temperature program can be controlled by an external device. So how does the sample preparation work? So again, as in DUC, the proper sample preparation is essential for reliable TGA results. We typically use a small uniform amount of material, around 5 to 20 milligrams. The sample should be, again, clean, dry, and um, free from any moisture or contaminants that can affect the mass loss results. The material is placed in a crucible, often made of platinum or alumina, and care is taken to avoid overloading uh, the balance. So you cannot overload a lot of samples because this is highly sensitive, to ensure accurate and repeatable measurements. So during the TGA testing, the instrument continuously monitors the mass loss of the sample as the temperature increases. The heating rate is always kept constant, often used at 10 degrees per minute in case of polymeric composites, but it can be adjusted based on the material type, definitely. We can also control the atmosphere using nitrogen or inert conditions, or air, to study the oxidation behavior. So depending upon the type of gas we use, we are going to obtain a specific result. So the result is a curve that shows the mass change with temperature, giving a clear decomposition profile of the material. If you can see here, this is the weight loss versus temperature curve, where you can see different transition or degradation steps in the polymeric based material. So you can also see a new peak here, the DTG. What is DTG? DTG stands for the derivative thermogravimetry, um, which is a way of looking the TGA results more closely. Instead of just seeing how much mass is lost, a DTG shows how much fast the mass is lost at each temperature. So the rapid transition that happens at a specific temperature can be analyzed using the DTG peaks. This makes it easier to pinpoint the exact temperatures where decomposition or the um, other changes happens more rapidly. Also, DTG is especially helpful when multiple thermal events overlap, as it provides a clear separation of those events. So how do you interpret the data? So there are basically three zones in a TGA graph. One, the first degradation, which can be due to the presence of different volatiles and moisture that is present in the sample. The polymer degradation, where the material degrades at a specific temperature. Also, the DTG graph here explains the derivative weight loss at the specific temperature, how much mass has been lost at the specific temperature, and the residue. So this plays an important role in polymeric matrix composite that is used for aerospace application, as materials with a higher residue usually constitute for the amount of filler or the reinforcement that is used in the composite. Also, the initial weight loss or the degradation due to moisture plays a vital role, because the presence of moisture or any other volatile material can play a crucial role in high temperature applications. So basically, the middle region gives us an important point about when does the material starts to decompose and what is the safe operating temperature of that specific material, and what happens if you're going to um, cross those temperatures, and how does the thermal degradation pattern works. So these are the basic things that is given by the TGA characterization. Discussing about the limitations, the TGA provides only the mass change information and no direct chemical identification, like in the case of a DSC analysis. Further, it cannot reveal any microstructure or morphology. Also, has a limited sensitivity for detecting very small mass losses. If there is a specific material that degrades at a specific temperature, but only a very small proportion of the material is being used in in the overall composite, then it is really difficult to understand uh, the degradation pattern of such small quantities of material. Also, it requires a controlled atmosphere, which results can vary with oxygen, nitrogen, or air. So based on the based on the application, we use specific gases. Also, we need to maintain a constant heating rate and the sample size for having an effective accuracy. Another important characterization for polymer composites that are used in various applications is its mechanical properties. So what is mechanical properties? The mechanical properties describe how the material responds to the application of an external force or load. Also, they indicate the strength, stiffness, and the flexibility and resistance to deformation or failure under the application of such load. Majority of the mechanical properties are tested using a universal testing machine. So if you can see here, this is a universal testing machine. Uh, the basic components of these machine are the load cell, which is going to give the specific amount of load, which is also a sensitive sensor that measures the exact force applied to the specimen. It converts this force into an electrical signal that the system can read. The other important part of the instrument is the crosshead, which is used to pull the sample up and down. It applies either tension or compression to the sample. Also attached to the crosshead, we have the grips or fixtures, which securely holds the test specimen in place in order to perform accurate measurements. The type of grips we use depend upon the testings being performed, which I'll be discussing in the upcoming slides. At the bottom, there is an actuator, which is basically the driving mechanism that controls the movement of the crosshead. And finally, we have the control panel on the software, which allows the operator to control the test, set parameters, and collect the data in real time. The software typically displays the force, displacement, and other critical values that are obtained during the test. Together, all these components make the universal testing machine, which is going to provide us accurate measurements when subjected to the characterization. One important type of mechanical properties is the tensile measurements. This refers to the testing which determines how the material behaves when it is pulled apart. It also determines the ability of the material to break under tension. Uh, so basically, this characterization involves stretching of the specimen until it breaks, while measuring the force and the elongation of the sample before failure. ASTM 3039 is generally used for characterizing polymer matrix composites. So in this standard, the samples are pre-conditioned at 60 degrees Celsius for 48 hours before subjecting it to the characterization. Also, as per the standards, separation speed of 2 millimeters per minute is used in order to obtain more accurate results. So this is a typical sample size for a composite material when subjected to the tensile testing as per ASTM D 3039, where the gauge length is 150 millimeters and the head is 40 millimeters each. Also, these uh, these heads are uh, equipped with rubber grips in order not to damage the sample, which plays by the grips, which plays an important role in characterizing and evaluating the properties of these materials. So this is the ASTM 3039 grip that is used for analyzing the tensile measurements of a composite material. So as you can see here, the grips pull the sample apart. The grips which are attached to the load cell pulls the sample apart, um, and the strength it can withstand and the elongation and break or the fracture point can be determined with the result. So this is a stress strain curve that is usually obtained from the tensile measurements. So what are the different regions of this curve? The first is the elastic region, where the stress and strain increase proportionally. And then comes the plastic region, where the plastic deformation occurs. Uh, the ultimate tensile strength is the point where at which the material can withstand maximum tensile strength. The stress is maximum at this point. Also, the yield point talks about the point where the plastic deformation begins. So the elastic deformation, the elastic deformation stops here and the plastic deformation begins. Also, the slope until the yield point determines the Young's modulus of the material. The point at which the sample breaks completely is the failure point. And these measurements can be used to obtain the tensile properties of the specific material that is being tested. Another important characterization is the compression measurements, which works in the reverse way of the tensile measurements. So the ability of the material to withstand compressive forces without failure. It also determines how much load can the material bear when it is compressed or squeezed. A standard test involves applying compressive forces to a specimen until deformation or failure occurs. It is commonly used to evaluate the load bearing capacity in structural applications, such as aerospace, wings, etc., which experience excessive compression pressure due to the atmosphere. ASTM 695 is the standard used for this characterization. So this is a typical characterization specimen size and the grip used. You can see here the gauge length is around 1.5 inches, and the width of the specimen, width of the test area is zero point 0.5 inches. The width of the Total specimen is around 0.75 inches, and the circular radius of the neck is around 1.5 inches. So these are the standard specimen size for testing the compressive. Sorry, any questions?
No, no, no. Carry on.
Uh, Um, so these are the standard size for of the specimen for testing the material, as per ASTMD 695 characterization. So this is the grip used, which is connected again to the load cell, and a compressive force is applied to the specimen. Uh, so this is a typical stress strain curve under compression. Uh, where you can see the similar points, and the maximum compressive strength is at which the stress is maximum. Also, the proportional limit at which the linearity of the curve changes. So this is very similar to the tensile curve. Another important mechanical characterization is flexural measurements. So these refer to the ability of materials to resist deformation under bending load. So earlier we have discussed under the tension load, which is pulling apart, under the compression load, which is pressing the sample, and now this is the bending load. This represents the maximum stress of a material that can withstand before yielding in a failure test. A standard test involves placing a specimen on two supports and applying a central load until failure. Important for evaluating, like this is an important characterization for evaluating the structural stiffness and the resistance of bending of the specific composite material. Generally, the ASTMD 790 standard is used to test composites for the flexural strength. So this is a typical sample that is used for the characterization, and this is the 3-point bending test, where the length between the two bottom loads is 60 millimeters, and the total length of the specimen is 120 millimeters, and the thickness of the specimen is 4 millimeters. So as you can see here, the different grip is used, and the sample is placed between the bottom two sample holder, and the load is applied uh, through the top loading unit, which is connected to uh, the load cell, and the data is recorded. So this is obtained from the literature, is a flexural strength of different materials, where you can see the strength versus elongation is marked. And also this is similar to the other two mechanical curves which we discussed earlier. So to conclude, the comprehensive characterization in aerospace composites cannot be overstated. We have seen how different techniques such as the FTAR, DAC, TGA, and mechanical test work together to give us a complete understanding of these materials. Each method reveals us different aspects, the chemical structure, as in case of FTAR characterization, the thermal stability, as in case of TGA and DAC, and the mechanical performance to evaluate the strength, stiffness, and durability of the material was being discussed. This information is highly essential for selecting the right material, predicting how it will behave in harsh aerospace environments, and ensure long-term reliability. With growing demands for stronger, lighter, and more resilient materials, advancement and characterization will continue to support the innovation and safely you utilize these material in the aerospace sector. Thank you so much for this opportunity from the department, and thank you, audience, for taking your time to listen to this presentation.
Okay, thank you, Mr. Sriram, for your insight for last 1 hour, insight on the different characterization techniques
Thank you, Professor.
for composites. And now, participants, if you have any queries, we'll take some 3-4. Anyone have any queries? You are free to ask. And
Hello.
Hello, Dr. Manish.
Yeah. Sriram, it was a wonderful presentation.
Thank you so much.
Yeah, I have not a query from this presentation, but apart from it, I just want to
Mhm.
know, because I'm a faculty here in HBTI Kanpur.
Mhm.
So I just want to know, means what are the scholarships are possible for the students who are applying from India. So
Mhm.
suppose they want to pursue higher education, particularly in Ph.D. in polymers or something. So can
Mhm.
you
Mhm.
suggest some scholarships for us?
So what basically happens is that you can apply for the Fulbright scholarship, which gives
Mhm.
you 100% education is covered, and once you come into the US, you can actually work as a teaching assistant or a research assistant, which is going to pay you on a yearly basis to get into the like to cover your accommodation and housing expenses. Typically in the US, like most of the universities, if you apply, like there are various application deadlines. So one is the early bird, then one is the regular, and one is the late application. So if you generally apply in the early bird deadline, you tend to get the scholarship if you have a good profile. So it is pretty
Mhm.
much that how do you build your profile during the course of your undergraduate, if they're directly coming from undergraduate, or undergraduate and masters if they're coming after a master's. So once you have a good profile, and if you have all your IELTS and other requirements done before the early bird registration, and you apply during that deadline, you get a good scholarship if your profile is shortlisted.
Mhm. So you are
So
also under this Fulbright fellowship, or you have some other?
no, I'm not under Fulbright fellowship. So my master's fellowship came from two different organization. My
Okay.
department in RIT, they gave me 50%, and American Packaging Innovation Lab, where I was the student manager, so they gave me 50%. So I did not apply for any
Mhm.
scholarship. So this was directly given by the institution based on my profile and
Profile.
everything.
Mhm. Mhm.
Also, in case of my PhD, that was the same thing. I did not apply in the early bird. I applied during the mid my expertise before. So I directly switched my master's into so they gave me the scholarship directly. I did not apply specifically for any scholarships. It's just fortunate to be awarded one from the various organizations.
Mhm. And for the master level also, that there is some scholarship for Indian students, or like PhD you have told.
Yeah, yeah, it's the same thing. So in the US, it usually works like this. It's undergraduate and graduate studies. So
Mhm.
your graduate studies compasses of both masters and the PhD. So
Okay.
whatever scholarship that covers the masters is also cover your PhD. So the couple of scholarships, or the one scholarship which I told you, it's the Fulbright scholarship that covers your graduate studies. So which is for both your masters and your PhD.
Mhm. Thanks a lot, Srinivasan.
Hey, of course, of course. Thank you so much, Dr.
Yeah.
Manish.
Best wishes from my side.
Yeah, thank you so much. Thank you.
Okay. Take care. Bye bye.
if no other queries, I thanks Mr. Sriram for his uh, valuable talk, as well as actually spending time with us with his busy schedule.
Thank you,
Thank
Professor.
you, thank you, thank you, Sriram.
Thank you, Professor. Thank you.
Okay.
Have a nice rest of your day.
Okay, fine. So now participants, if anybody want, actually at least some 2, 3, please unmute yourself and make your video also on to give some type of small feedback. Any 2, 3 members, please. For the overall things what happened actually.
Good evening, sir. This is
Yeah,
Manish.
yeah.
Yeah, sir. So, I told earlier also that I have a very fond memory of Crescent College long back.
Okay.
And it is very indeed good that I have once again associated with this by this conference. As actually one of our MTech students has sent me this link
Hmm.
to attend this 1 week FDP program. So last year I organized an FDP program in our department. So I know how much effort we should give, and entirely we have to sit. Means that we have to take everything. Means the program schedule, and we have to put a lot of effort. So I congrats you for the successful completion of this FDP program today, and to your entire team members. And let's see when I will be there in Chennai. So definitely I will visit your department.
Okay,
So
you're most welcome, Dr. Satish, and anything actually can do from our side. We are
yeah,
always
thank you, sir.
कुछ भी
So
actually help, कुछ भी चाहिए तो हम लोग कर ले.
sure, sir. Sure. Thank you, sir.
Okay,
Last
okay.
time, last time when I came in 2010, at that time I was almost means I was in the submitting of my MTech thesis.
Okay, okay.
In the month of
Luckily did
February.
PhD and okay, fine.
Yeah. Then
Okay.
later I did my PhD from IIT Guwahati and did postdoc in Europe.
Oh, okay, great.
So everything I am in polymers only.
Okay, okay. So anyway, we'll be associated again actually. Okay.
Sure.
Never knows actually. We never knows about your college is offering this polymer program. Actually, we have a data
This
of
is one
other.
of the, in North India, there is one IIT Delhi.
Hmm.
So they have the polymer science department. Now they have changed to
Material science.
metal science and engineering.
Hmm.
And but our department is one of the oldest department in India. It started in 1965.
Acha, acha, acha. Oh, great.
Then initially it was giving 3-year degree for BSc something. Then it changed into BTech program. So then gradually it also giving MTech and PhD program. So it's a long journey for our department.
Okay, fine. So we'll be connected actually future.
Yeah, sure.
Okay, thank you, Dr. Manish, for your.
Thank you, sir.
Any other, Geeta madam, you want to tell something?
Sir, so thank you, sir. So wonderfully organized all the sessions. So I am basically from chemical engineering, so I have no idea regarding this polymer. So aerospace application polymer science. So that is why but I attended all the sessions. All the sessions are very informative, sir. So thank you for organizing this wonderfully FDP. So thank you so much.
Okay, thank you, madam. Actually, so anything actually because this polymer is applicable to not only this aerospace
Chemical
and
engineering also. Yeah,
yeah,
it is also applicable to
yeah,
chemical engineering.
yeah. So it's used in civil, it is used in actually electrical, electronics, everywhere actually.
Yeah.
Oh, in biomedical as well as they are making the things. Okay, thank you,
But I
madam.
attended. So thank you, sir. Thank you so much.
Any one more participant, please.
Good evening, Professor. This is Kaliraj from Tamil Nadu Government Polytechnic College, Madurai.
Okay. Thank you, sir. Carry on.
Very good informative sessions. All sessions were very good. Very, eminent speakers. They gave a very good experience. It is a very a rememberable FDP actually. The speakers were spread from research to the end use. So it is a good
Yes, sir.
collaborative FDP. So I thank you for organizing this FDP. Thank you, sir.
Okay, sir. Okay, sir. This is not myself alone. Actually,
Yes,
this
yes.
actually the teamwork of head of the Department of Polymer Engineering, where I helped actually whatever possible from my side, as well as HOD Aerospace and our other coordinator from Aerospace. So all together, the things has been happened, and we'll be happy actually if any further things. And as I already told earlier also, that meant as in Chennai actually you have the flexibility of because a lot of polymer industries are there, whether it will we will talk about actually plastic or rubber. So many, although in Madurai also actually many things are there.
Yes, sir. Yes, sir.
So anything actually together, actually, if you need any help from our side, we can, and if we need anything, we will win.
Yes, sir. Yes, sir.
So that is the thing, that is the way in which actually things is to move.
The KCG College of Engineering, I think it is in near Padappai also. They are also having aerospace engineering, aeronautical engineering.
Yeah, KCG is actually in old Mahabalipuram road.
Yes, yes, yes.
Yeah, because that is a Hindustan group, so they have
Yes, sir.
well-established aerospace departments.
Aerospace. Okay. Sir.
Good evening,
Thank
sir.
you, sir.
Yeah, tell me,
Good
sir.
evening, sir. This is Vijayan from Satyabama University.
Okay,
Actually, I am so happy about that title. All the sessions are very, very related to close with the PM. No sessions are deviated from anywhere. I'm from aeronautical department. I gain more and more knowledge from this expertise. Even 3D printing I'm working on that day also. PMC polymer composite also. Everything is very, very useful, and thank you so much, sir. I am happy on that everything. Thank you, sir.
Okay, Professor, actually, because through this you might have got more ideas of actually in institute level, as you are working in a private university,
Yes.
we are also, we have some limitations somewhere actually we cannot, but when you will collaborate with some industry, then the thing will be actually, that means end use application type of things will happen, and that will be more appreciated.
Yes, sir. Yes, sir. Even time also very satisfied. College time we are engaged. In this time also we are relaxed and listen everything.
Yeah.
Sure, sir. Sure. Thank you, sir.
Okay, thank you. Okay, so thank you all for actively participated in this program, and please, today actually I sent three numbers of feedback. One is for session 1, session 2, as well as one more we need actually for the overall thing. So please complete that. I shared in the chat box, as well as actually I sent to you in our FDP group. And hopefully actually within a week or 10 days, you may get your certificates after completing, after the due is signed by our people, and so that will be communicated to you. Okay, thank you all for attending this program. So I am leaving. Thank you all.
Thank you, sir.